This is the introduction to section 7.3 where we'll be adding and subtracting rational expressions. What I'd like to do right now is go through the guidelines of performing such an operation. And I want to do it under the guise of these two problems I have in purple down here. One is just adding fractions and one's an actual rational expression. So let's take a look at the similarities and how both of these guidelines are going to apply in both of these scenarios. So, guidelines for adding and subtracting rational functions. The first thing that you want to do here is you want to factor all denominators. For any terms without a denominator, express that term as a fraction over 1. So what we have here is as follows. This is 2 over 18 is 2 times 3 times 3, or 2 over 2 times 3 squared, plus 3 over 75. 3 over 75 is 3 over 3 times 5, which is plus 3 over 3 times 5 squared. And then what we have is this 2, which we can write as 2 over 1. Similarly, on the right here, for these expressions that are rational, we just factor the denominators. This is x plus 1. This denominator of x squared minus 9, that's a difference of squares, so it'll factor as an x minus 3 and x plus 3 minus x plus 2 divided by, if we carefully reverse FOIL this here, we'll get x plus 3 times x minus 2 for our denominator. And then this x can be rewritten as x over 1. So in both cases, it's pretty similar. You're going to want to factor those denominators as much as possible into its prime factors. And if you have any term that isn't starting out looking like a fraction, like this 2 or this x, then rewrite it as a 2 over 1, or in this case, an x over 1. Okay. After we do that, we're going to determine the least common denominator for all denominators in the entire expression. Each factor of all denominators must be represented in the LCD. Further, each factor should have a multiplicity, we'll talk about that in a minute, a multiplicity equal to the highest power of that factor occurring in any one denominator. So that's a pretty wordy guideline there, but it's pretty straightforward once you know what you're looking for. So let's talk about that. So let's grab these expressions here. We'll grab this one, bring it on down, and we'll grab this one, and we'll bring it on down over here. So what we have here is, if we rewrite this, or I should say this is 2 over 2 to the first power times 3 squared plus 3 over 3 to the first power times 5 squared plus 2 over, well, just 1. So when we get the LCD, let's talk about what that LCD is going to be. The LCD here is going to have one of each factor. So it's going to have a factor of 2, a factor of 3, and a factor of 5. And we don't often write a factor of 1, but you can if you want to. Now, they both have a factor of 3, but I'm only going to represent that factor 3 one time. So my LCD should start out as 2 times 3 times 5. So those are our each factor. So these are all factors, or I should say all distinct factors, all different factors. All distinct factors. Distinct meaning they're not the same. All distinct factors from every denominator. And now what we're going to go do is we're going to look at the denominator factor 2 in each one of these expressions. And if you wanted, if it's missing a factor, you could actually put this in here. This is 2 to the 0, and this is 2 to the 0, 3 to the 0, and 5 to the 0 power, since they're effectively ones, and this has a 5 to the 0. But we're going to look at each one of these denominators, and we're just going to grab the largest power of 2. This is what's called its multiplicity, how many times it's repeated. And so of the 3 factors of 2 that I have, 1 for each denominator, and I'm including this 0 power of 2 here. So I have a 0 power of 2, a 0 power of 2, and a first power of 2. So the highest of those 3 is that first power, so that's the power that I'm going to put on 2 for my LCD. I'm now going to go back and look at the factors of 3. This factor of 3 has a square, this factor of 3 has a first power, and this factor of 3 has a 0 power. So the highest occurring factor of 3 in any one denominator, the highest power of 3 in any one denominator is 2. And then finally, if I look at all 3 powers of 5, I have a 0 power, a 2 power, and a 0 power, which means that I'm going to be using the second power of 2. And so my LCD in this case turns out to be 2 times 9 times 25, which is 450. So that is the least common denominator here. But typically, we work with this form. It's probably not best that you multiply that out, although it's nice to know that it's 450. Technically, we're not going to be multiplying them out for our next step. Similarly, over here, if I just put powers on each one of these, my LCD is going to consist of 1 of each factor. So I got an x minus 3, I got an x plus 3, and I got an x minus 2. And I could write a 1 on the end there, but multiplying by 1 isn't going to do anything. So again, we have this idea of all distinct factors from every denominator. And now we're going to go back, and I guess I should have highlighted this, power of 2 and power of 2. We're going to go through and we're going to grab the highest occurring power of each one. Now for x minus 3, that only occurs in this denominator, and the highest power is 1. So that's the power that we're going to be using on x minus 3. For x plus 3 actually appears in both denominators, but it's a tie. They both occur to the power of 1, so neither one of those is larger, so we'll just take our pick, and we'll still use the power of 1. And then for x minus 2, that only occurs in this denominator, and the highest occurring power of it is 1. So we'll use that as well. And that's actually our LCD. And we're not going to multiply it out. There it is. So if I wanted to rewrite this again, I would just say, well, that's x minus 3 times x plus 3 times x minus 2. So now we have our LCDs. So the question is, how are we going to use them? Well, that's the next step. So let's talk about that. Multiply each term, top and bottom, by the missing factor or factors, if there's more than one, needed to complete the least common denominator. So let's take a look at that with our fraction. So let me grab this guy and we'll duplicate him again. Bring him down here. And I'm going to duplicate him actually again. Or I'll just move some stuff over here. Make some room. Need just a little bit of room. Okay, so let's not forget what our LCD is. Our LCD here is 2 times 3 squared times 5 squared. And we got to talk about what each one is missing. So in our first LCD, we have a 2, that's good. We have an entire 3 squared, that's good, but we're missing the 5 squared. So we're going to take 5 squared and we're going to multiply top and bottom by 5 squared. This was the missing factor. And that's going to get a little clunky here. Hold on, let me try that again. Get a better representation for this. I'll do it underneath each fraction. So let's see. 2 times 3 squared times 5 squared is the LCD. And I'll get another one over here, 2 times 3 squared times 5 squared. And another one over here, 2 times 3 squared times 5 squared. And we just got to look and see what they have in common and what they're missing. So again, this one was missing the 5 squared top and bottom. In my next expression, we have a 3 and we have a 5 squared. So we have one factor of 3 and we have a 5 squared. So let's see. If I rewrite this LCD a little bit so that it's a little bit clearer to see. This is 2 times 3 times 3 times 5 squared. And I already have one factor of 3 and one factor of 5 squared. So what am I missing? I'm missing a factor of 2 and I'm missing a factor of 3. So we're going to need to bring each one of those factors into play here. 2 over 2, 3 over 3. Or you could just write times 6 over 6. That would be fine as well. And then for the last one, we're actually missing every single denominator factor. So we're going to need a factor of 2 over 2. We're going to need a factor of 3 squared over 3 squared. And we're going to need a factor of 5 squared over 5 squared. And the result is going to be, well, we'll do the result in the next step. So that's us obtaining a common denominator. Done. Check. Let's try it again with this expression here. Is very similar. Let's duplicate this. So again, if I clean this up and write the LCD underneath each one of these and arrange this so we have a little bit more room. Let's see. The LCD was x minus 3, x plus 3, x minus 2. So in this first expression, we have the x minus 3, we have the x plus 3, but we're missing the x minus 2. So we need to multiply top and bottom, by x minus 2, not plus 2. X minus 2 over x minus 2. In the next expression, or term, we have our LCD is x minus 3, x plus 3, x minus 2. This time, however, we have the x plus 3 and the x minus 2, but we're missing the x minus 3. So we're going to use that one. X minus 3 over x minus 3. And then for our last factor, the LCD isn't changed. X minus 3, x plus 3, x minus 2. But again, this one is missing all three factors. So we have the missing factors, and we're going to use all of them. So we're going to have x minus 3 over x minus 3, x plus 3 over x plus 3, and x minus 2 over x minus 2. Oops. And now we'll have a common denominator. Okay. Let's move this up a little bit. Our next step in this process, collect all the numerators using the appropriate addition or subtraction over the LCD in one large fraction. So what am I talking about there? Well, let's start with this expression that we have here. This is going to be equal to one large fraction over the LCD, and the LCD is 2 times 3 squared times 5 squared. So this is our LCD in our one large fraction. And then the numerators are going to be from the first expression, 2 times 5 squared. Plus, that's using the appropriate addition here, plus 3 times 2 times 3, plus 2 times 2 times 3 squared times 5 squared, where that was the third numerator. So now we've combined them into one large fraction. We got a little bit of arithmetic to do. And remember, you can't just start canceling right now because of the fact that this is addition in the numerator. Or if it was subtraction, you wouldn't be able to cancel either. You'd have to clean up this numerator first. Okay. In a similar manner, if we take this rational expression, duplicate that, and do some similar arithmetic. Clean this up a little bit. Get rid of some of that highlighter and some of those arrows. So similarly, what we're going to do is this is going to be equal to a big old fraction. And this one's a little bit overkill with the number of terms we have, but I'm just trying to illustrate a point. That is our LCD in our one large fraction. And then we have our first numerator, which is x plus 1 times x minus 2 minus x plus 2 times x minus 3 plus, this one's a little bit messy here, x minus 3, x plus 3, x minus 2. Boom. So that's how we would combine it into one large fraction. Okay. The next step, simplify the numerator. Okay. What does that mean? Well, let's go back here and let's grab this expression. Let's grab all of it here. Duplicate. I'll bring this sucker down. Let me simplify the little drawing here and get rid of some of this extra notation. So what do we have? Now, note that it just says simplify the numerator. It doesn't say simplify the denominator. So I don't want you multiplying out the denominator, but this is 2 times 5 times 5. That's 50. Plus 2 times 3 times 3. That's 18. Plus 2 times 2 is 4. So let's see. 2 times 2 is 4. Times 9 is 36. Times 25. Yikes. 36 times 25. Let's do some arithmetic. 36 times 25 is 30 plus 6 times 20 plus 5. And if I FOIL that, I'll get 600 plus 150 plus 120 plus 30. So what is that? 600, 750, 870, 890? Is that even right? 890, I guess. Hope I did that right. 6, 7, 8, 90. Well, that's a 30. 900. Sorry. This is 900. That's better. Oh, yeah. 25 times 4 is 100. Times 9 is 900. Check. Good. All over 2 times 3 times 5 squared, which turns out to be 968 over 2 times 3 times 5 squared. So that's done. We have simplified the numerator. Combined like terms, if you will. Now we're going to do something similar with this expression. So similarly, what we have here, we got to do a bunch of foiling here. So let's see, this is x squared minus 2x plus x is going to be a minus x minus 2 minus the quantity x squared minus 3x plus 2x is going to be a negative x minus 6 plus, I'm going to group these together a little bit differently. I'm going to group these two together. So that's x squared minus 2x. And if I multiply these out, that's a difference of squares, and that's going to give me x squared minus 9. And this is still all over x minus 3, x plus 3, x minus 2. Let me move this next direction set down a little bit, make some room. Okay. Now let's keep simplifying. This is x squared minus x minus 2. I'll distribute this negative sign. Negative x squared plus x plus 6. And now I got to do some foiling here. This is going to be plus x to the 4th minus 9x squared minus 2x cubed plus 18x all over x minus 3, x plus 3, x minus 2, which is equal to, now we're going to collect like terms here. It looks like these x squareds are going to cancel, and I have, anything else going to cancel? Well, we'll get there. Let's see. I have 1/4 power term, so I have an x to the 4th. I have 1 cubic term, negative 2x cubed. I'm on to my squares now. We were doing those in blue. Those two canceled. My next square is this guy, negative 9x squared. And then we need to do our x's. Let's see. Negative x, positive x. Those guys are going to cancel. And then I'm left with 18x plus 18x. And let's see. For our constant terms, we have a negative 2. Oops, I already used that color. Sorry. We have a negative 2 and a positive 6, making this positive 4. All over x minus 3, x plus 3, x minus 2. Now, we don't yet know how to factor something as crazy as x to the 4th minus 2x cubed minus 9x squared plus 18x plus 4. So this will leave in unfactored form. If I could factor it, I would then be able to move on to the next step, which is factor the simplified numerator to determine if the expression can be simplified by canceling any common factors. So let's take a look at that here in our little fraction. For our little fraction, we might try to factor 968. At least we could probably pull a 2 out of there. Let's see, 2 goes into 8 4 times, 2 goes into 6 3 times, and 2 goes into 9 4.5 times. So 484, 2 times 484, over 2 times 3 times 5 squared. Isn't it a 3 squared? This should be a 3 squared. I missed that back there. 3 squared, 3 squared. So we got a common factor of 2, and this is 444 over 3 squared times 5 squared. 5 doesn't go into 484, and 3 doesn't go into 484, so this is simplified, and this is 484 over 9 times 25, which is 225, and that's our simplified fraction. So there was no more common factors. And as I said before, in a similar fashion, we would try to do something here. Oops. We would try to do something like that here. However, we're going to leave an unfactored form because we simply can't factor that at this time. We might be able to do it in the future, but as of right now, it's not the case. Okay. So those are the guidelines. We're going to do some examples following those guidelines in the next video.